Ready, start. Need for deep tech startup ecosystem. The phrase deep tech startup does not have a precise definition, but there is a broad consensus on what it is. Deep tech startups arise from research based disruptive innovations from STEM labs of academic/research institutions and solve hard problems and challenges. Some examples are A. Recycling sewage to get clean water at an affordable cost. B. A low cost solution at scale for curing blindness. C. Affordable solutions for treating diseases such as diabetes, dementia, cancer, etc. D. Creating an alternative to lithium ion batteries. And E. Low cost satellite launching systems. There are three major problems that deep tech startups have vice other startups, including those that are called tech based startups. 1. Deep tech startups need a longer gestation for development than other startups. The latter might need from 1 to 3 years to reach revenue, while deep tech startups need 5 to 8 years. 2. Deep tech startups require different types of inputs. They require more patient capital, specialized talent, and expert knowledge in more than one domain to develop and validate a science based innovation to the point where it is acceptable to commercial investors. For example, assume an invention involving creating a new substance under bracket say a chemical that removes heavy water from water. It takes time and resources to test and validate samples, obtain regulatory approvals, and set up a new manufacturing process to produce at scale. All these are capital intensive, time consuming, and have no assurance of success. 3. A deep tech startup follows a different development path than other startups. A deep tech startup derives its IP from the underlying science. The startup has to work backwards and find a real life problem that is worth solving using its technology and validate the adequacy and nature of the market demand for the innovation. Therefore, deep tech startups take more time, talent, and capital to develop up to when commercial investors find them acceptable. The risk of failure is high at every single stage for a deep tech startup, usually higher than in the case of other types of startups, but the payoffs of successful deep tech startups are tremendous. Think of Microsoft, Google, Apple, Intel, Tesla, Moderna, SpaceX, etc. They are large corporations today, but they started as mere technology bets not very long ago. India has also created a few deep tech startups over the past decade whose impact has been overwhelmingly positive. It lends credence to the suggestion to step up policy and financial support to the deep tech startup ecosystem. Creating ecosystem. India has produced about 94 unicorns so far, but barely any of them can claim to be a deep tech startup. We have several venture funds in India, but most pursue relatively lower risk investment opportunities that exploit India's growing consumption economy or those making cloned products. While India has a problem of inadequate R&D expenditure for an economy of her size, there is a sufficient amount of high quality research in India's top STEM colleges to fuel a deep tech startup revolution. Some key reasons why our academic researchers lab in their potential to convert research into deep tech startups are: 1. There is inadequate appreciation amongst policymakers and university administrators for the need to build capacity among academic researchers, scientists, and STEM students in India to truly understand what entrepreneurship entails and what commercialization of research means. Being formally trained in science and technology but not having adequate exposure to the real world of business/commerce, academic researchers conflate invention and innovation. There is a big difference between making a successful technological breakthrough in the lab and building a successful enterprise around it. Becoming entrepreneurial cannot be imbibed by reading or scholastic programs, but only through experiential learning and expert mentoring/coaching. 2. While government has made good efforts to fund innovation in universities through programs such as prototype development, filing for IPR, incubation, etc., few academics under bracket less than 5% commercialize their research by startups. A key point is that even if academies aspire to convert their inventions into enterprises, they do not have the mental makeup under bracket the entrepreneur's mindset or the knowledge of how to organize what they have and collaborate with others to get what they do not have/know. Many universities have set up incubators to help with this, but they are not adequately equipped or incentivized to commercialize research. Although they are not for profit entities, incubators look for startups that have a good chance to be commercially viable. With their limited budgets, incubators face a tough challenge to nurture startups to scale their revenues and become stop